Dober dan, dobrodošli vsi udeleženci današnjega spletnega webinarja, ki je letošnji prvi, ki ga pripravljamo v podjetju VELUX Slovenija, na temo prezračevanje stavb in ohlajevanje stavb s pomočjo prezračevanja z osredotočenostjo na vlogo naravnega prezračevanja. Veseli me, da je današnji gost in predavatelj Christofferjem Plesnerjem z nami. Z vami sem pa tudi Neža Močnik. In tisti, ki me še ne poznate, ker danes je kar nekaj verjetno tudi novih udeležencev, kar nas vsakič veseli, da se pridružujete novi. Sem Neža Močnik, arhitektka, diplomirana arhitektka, nekaj časa v praksi, potem pa stopila v podjetje VELUX Slovenija, dobrih 20 let nazaj, kjer pokrivam predvsem področje kakovosti notranjega okolja. V podjetju smo osredotočeni na dnevno svetlobo in svet v zrakoprostorih in iz tega vidika tudi poskušamo vsebine, ki jih raziskujemo, ki generiramo, prenašati na stroko in tudi naprej na splošno javnost. Tako, Christofferja bom predstavila malenkost kasneje, ko mu predam besedo. Za začetek pa par besed. Skupaj bomo dobro uro, potem odpremo možnost za vaša vprašanja, ki jih pišite tudi v pogovorno okno. Večina predavanja s strani Christofferja bo v angleškem jeziku, tako da če je kakšen zadržek pri vprašanjih, jih normalno zapišite v slovenski jezik in bom potem jaz v slovenščini bom jaz potem prevedla Christofferju vprašanje. Opozorilo, da se webinar snema zaradi GDPR-ja, se pravi tisti, če imate vklopljene kamere in ne želite biti vidni, kamere prosim izklopite. Seveda bo pa posnetek objavljen na naši spletni strani, tako kot v vseh webinarjih do sedaj, ki jih vidite, tako da tudi dobrodošlo in vabljeni, da si webinarje pretekle morda tudi pogledate in v njih najdete zanimivo vsebino, iz katere boste lahko črpali tudi druge informacije. Kaj je vsebina današnjega webinarja? Kar veliko stvari imamo nekako na agendi. Tele okrepljene točke so tiste, katere bo približal vam Christoffer. Začel bo z nekaj podatki o vlogi prezračevanja znotraj bivalnega ugodja. Govorili bomo tudi o razlogih in načinih prezračevanja stavb, o energijski učinkovitosti, o pregrevanju stavb, o vlogi senčil. Seveda je Christoffer tudi vodja dveh delovnih skupin na področju prezračevanja, tako da bo tukaj zagotovo tudi nekaj zanimivih informacij, predvsem tudi za tiste, ki ste se pridružili nam s strani inženirske stroke. Potem prevzamem besedo jaz nazaj v slovenščino, kjer bomo pogledali še par primerov iz prakse in potem tista klasika, napotki za pridobitev kreditnih točk in pa vprašanja odgovori. Zakaj smo izbrali to vsebino? Dejansko skozi raziskave, ki jih tudi sami lansiramo, je veliko zavedanje ljudi, da zdravje pomeni zdrav dom. Iznotraj te celice našega doma, stanovanja, kakorkoli, ljudje veliko pozornost namenjajo, kakšna količina dnevne svetlobe v prostoru in pa kakšen zrak dihajo. Podatki so zelo zgovorni in tema dvema dejavnikoma kakovosti notranjega okolja pripisujejo zelo veliko vrednost. Zanimivi podatki mogoče se nanašajo tudi na obstoječ stavbni fond, ki je trenutno v Evropi. Nedavne raziskave pokažejo, da praktično tretjina stavbnega fonda je takega, ki se spopada z določenimi pomanjkljivosti. Ali je to premalo dnevne svetlobe, ali je to prehrupen prostor, ali je prenizka temperatura, ali je pa v prostoru vlaga in pa seveda pojav plesni. Zdaj v Sloveniji so podatki mogoče še malo drugačni, sicer pa dosti podobni, je pa tukaj velik poudarek oziroma številka nekako odskoči na problematiko vlage in pa plesni v prostoru. 21% odstotkov ljudi od 33% populacije se sooča s problematiko vlage in plesni. Zaradi tega smo še toliko bolj pozorni na to, kako gradimo, kako prenavljamo in zaradi tega smo se tudi danes odločili, da tematiko namenimo prezračevanju in jo obdelamo z različnih vidikov. Tako da od zdaj naprej bom predala besedo Christofferju Plesnerju. Preden pa to naredim, mi dovolite, da ga še predstavim. Hello, Christoffer, I hope you are with us. Do we hear each other?
I'm here with you.
Great, great. Yeah, I've said a few slides before you start, but before I give the microphone to you, just let me introduce you. So, Christoffer Plesner works for VELUX as a senior ventilation specialist, and you're working for VELUX for more than 14 years now. You have a lot of experiences in indoor air quality and thermal comfort, related especially to ventilation and ventilative cooling. You have a background in Master of Science in Engineering and certified as a project manager. And you're deeply involved in standards, which are part of legislation, compliance tools, and strategic business responsibilities. Christoffer, you contributed to over more than 20 scientific publications and led multiple research projects. And your focus and high interest is building design and new building legislation. And you are chairman of 2 working groups for ventilation standards. I simplified a bit, but probably you will say a few words more if needed. So I hope I've said all necessary in introduction, correct?
It was perfect, thank you.
Yes, so welcome, Christoffer, once again, and I'm giving the microphone to you, and please lead us through the slides.
Thank you, Nisa, and hello, everybody. So today I'm pressing now.
Yeah, you should press the slide and it should go forward.
Yeah.
Okay.
Yeah, so I will start off by telling about well-being in buildings. So buildings must ensure good daylight conditions, view to outside, sufficient fresh airflows, and prevention of overheating, and also offer good connection to outside using windows, and also resilience. So the building should be resilient to, for example, if the power goes out. Buildings must be designed carefully, looking at the above points to create a building where you feel that you are in well-being. And on the right side, you see a figure showing that well-being is another part of health and comfort. So we want people to be in well-being, and also we want a good and robust building design by using the points that I just showed. And if we look at the holistic view of a building, we have what we call the indoor environmental quality, which is a lot of things. And in a building, we must take care of the environment, energy, and comfort. But if we look at the indoor environmental quality specifically, there are 4 points. One is thermal comfort, one is indoor air quality, and then you have lighting and you have acoustics. In this presentation, I will primarily focus on the first 2 points. Thermal comfort, that's for temperatures, and indoor air quality is, for example, for CO2. And as I said, there are many aspects to take into account, but also look at the energy use, look at the environment. So that is the sustainability part. And then there is, if you are in a building, there are things we can feel or sense. That is, for example, temperature. You can feel if it's too hot or cold. The light, you can also feel, and if there are bad smells. But then there are what we call the invisible indoor environmental quality, which are things we cannot sense. So that is, for example, radon, particles, substances and paint, materials. So that is things that we cannot sense. And for that, it is good to have, for example, sensors to register that for you. And if we go a little bit more into why we shall ventilate buildings, well, there are 5 points. The first point is health and comfort. We want to ensure that there is good supply of fresh air to reduce pollutants and allergens, which improves the respiratory health and overall comfort. Then there is indoor air quality. We want to control the indoor air quality by diluting and removing contaminants like CO2 and VOCs. For energy efficiency, we want to enhance this by regulating the indoor temperatures, reducing the need for example, cooling systems during the summer, because it's very intensive for the energy usage. We also want to prevent mold. We want to control the humidity levels to prevent the mold and the growth, and also protecting both health and building integrity. Safety, we want to reduce the concentration of hazardous gases and fumes, ensuring a safer environment for the occupants. Yes. I'm pressing, and then we have some ventilation definitions that we think you should know. So airing is if you open the window manually by the user through, for example, windows, doors, or other openings. Natural ventilation is an operating principle where you are basing it on the effect of wind and stack effect, where mechanical ventilation is another thing, that is if you base the principle on the operation of fans. And then we have hybrid ventilation, which is a combination of natural ventilation and mechanical ventilation. And then we have a term called ventilative cooling, which we also use in this presentation. And that is free cooling, where you use the outside temperature, aiming to improve the indoor thermal comfort or decreasing the cooling loads in the buildings. And this air transfer may be by natural, mechanical, or hybrid means. And for example, so the ventilative cooling is, for example, if you open the window and you can then cool the indoor air using the outside air, which doesn't cost a lot of money. And airing, as I said, it can allow to bring in fresh air and then the stale air to exit. And this is when you feel a need for something, and here you rely on the natural air movement and human feelings. It's a simple and immediate way to refresh the indoor air, often used in homes and small spaces, and is very good for quick peak pollutant removals. And then we go into ventilation, which can be by natural or mechanical means. And here you can see for natural, it can be using windows or vents. For mechanical, it can be using the fans or the whole HVAC system in a building. And ventilation allows, for example, good indoor quality by removing the pollutants, humidity, and to maintain a comfortable indoor environment. And it works well with sensors to ensure optimal indoor environmental quality and fulfillment of the regulations. And with sensors, it's sometimes easier because then you can register the pollutant that you want to dilute. There are 3 types of natural ventilation. The first type is single-sided ventilation, which you may have heard of. It's where you have one opening or more, but on the same facade. This is what we call single-sided ventilation. Then we have cross ventilation, which is when you ventilate across the building through openings in different parts of the facades. And this can both be through facade windows, but it can actually also be, if you have an attic, through the roof windows in your attic or in the top floor, as long as it's across the room or the building. Then we have stack effect ventilation, which is when the warmer air is lighter than the cold air, and then the warm air rises and the cold air sinks, and then you can remove the contaminants in the building because the hot air rises, and then you can escape it through the roof windows in the top of the room or building. So those are the 3 types of natural ventilation types. And of course, it's important to think of the design here. So if you know that you early on want to use stack effect ventilation, you really have to think of where can you have the facade openings and where can you have the roof openings, because the higher height difference you have between the supply and the extract, the more airflow you can get in your building. So for architects, it's very important to think of the design when you think of these three types of natural ventilation. Yeah, and going a little more into the stack ventilation. Here's a study showing a comparison where you have, you can say, mechanical ventilation on the left side. This is typically 0.5 air changes an hour. And then the right side, there are different types of natural ventilation. We looked at what happened if you do single-sided ventilation, cross ventilation, stack ventilation, and stack with cross. So if we look at mechanical ventilation, then it takes around 2 hours to fully renew the air in the room for this study. But if you use a combination of stack effect and cross ventilation, then you can get 10 air changes. So that's 20 times more. This means you can reduce the time from 2 hours down to 6 minutes. And here's a simplification that if you have 5 minutes of cross ventilation, this is the same as 25 to 50 minutes of mechanical ventilation. And the 25 and 50 minutes depending on if it's summer or winter. Then if you take 5 minutes with stack and cross ventilation, then you need 1 hour and 40 minutes of mechanical ventilation. So to achieve a good indoor environmental quality, the typical mechanical ventilation system alone is not enough. So there you often need to use stack ventilation with openable windows to achieve an airflow to dilute. For example, if you have a lot of people in a room or you have painted or something else. So this was just to show you the effect of openable windows in a building. And air change rate is the way that you usually, or sometimes in regulations, state the amount of air renewal in a building based off an airflow rate, which could be in cubic meters per hour. So you need to convert that into air changes. For energy efficiency, there are different solutions for health and energy efficiency. Natural ventilation is one. It's fast and intuitive. You can use operable windows, which are must-have in homes. For natural ventilation, there is a lack of heat recovery. And for mechanical ventilation, you can reduce the heat losses. It's independent from the user behavior. And it's less user-friendly and prone to failures. And this has been shown in many studies. But the best solution is usually the hybrid, which is a combination of both natural and mechanical. So then you can switch when the times are right. And this usually is good for the lowest total energy consumption in a building. So if we go a little more into the hybrid ventilation, what is that? It's many things, but as I say, it's a combination of natural and mechanical. So it can be that you want to run natural ventilation during the summer period and parts of the transition periods when there is a need to cool the building. Mechanical ventilation is very good during winter, where you can have heat recovery to recover some of the exhaust air that you are throwing out. And this is just a figure of how this can be shown, where you on the left side have the mechanical part during the winter, and the summer you open your windows to cool the building. And for the night time, it's very good with night cooling using openable windows. And then you can also have a natural ventilation system running what we call the basic ventilation, so it changes the air basically, and then you have mechanical ventilation assisting when the driving forces are not enough, so when they're low. And this is a fan that assists the natural airflow. You can also have a mechanical ventilation system running basic ventilation at least through the winter, and then you can assist with natural ventilation with openable windows when the outside weather is allowing natural ventilation to run. So there are many types of hybrid ventilation, but these are two typical types that we will talk about. So that now you know that. And energy efficiency and use of natural ventilation. So hybrid ventilation, as I told you about before, is usually the most energy efficient solution, combining both natural and hybrid. Natural ventilation, as I said, is good to save cooling energy, or actually we call it ventilative cooling. With openable windows, then you can save the cooling energy, so maybe you don't need as much air conditioning. Mechanical ventilation is good at saving the heating energy, so you don't lose all the heat in your building during winter because of the heat recovery. But the use of openable windows is an important aspect of hybrid ventilation because it's very cheap to open the windows and you can do it when the times are right. And here it's good to think of a sensor system, and we can always be part of sensor solutions. And on the right, you have a drawing of a house with different solutions. For example, the stack effect, as you see in the top, with roof windows in the top and facade windows in the bottom. And then you can have the stack effect because you have a height difference and you have an open floor plan. So when you design buildings, it's good to think of this open floor plan. And this is an example from the VELUX Home for Life project. Yeah, and then here's a study of you can say, the relevance of natural ventilation. And this was a study for a residential building. And on the study, you see that hybrid ventilation is more energy efficient than mechanical ventilation. So here it was comparing, on the left, you see mechanical ventilation, which is the bar, comparing to hybrid. So the mechanical with heat recovery is compared to hybrid, where you have mechanical and natural. So for the hybrid part, you have natural running in the summer period to save some energy. So because of this saved electricity during the warm periods and the use of mechanical ventilation in the cold and NV in the warmer periods, then you have this saving. And this gives a decrease in the total energy demand. You can see this on the right side, comparing 3 cities, Istanbul, Paris, and Copenhagen. And the blue is the fan power. So you can see for the hybrid, you use less fan power because you have natural ventilation run during the summer. So the decrease is largest with the automatic control, where you switch between the mechanical and natural. So you need a good control, of course, to have the best saving. And then there are benefits of the natural ventilation. So I think I mentioned it a little bit before, but it's a good solution for peak load situations. This can mean that let's say you have a party in your home, or you have a big meeting, or you have a lot of people gathered, then you have a lot of, you can say, CO2 and temperature and humidity emitting. And here it's very good to get rid of this polluted air quickly. And here we can use airing by opening the windows accordingly. It can also be when you cook or clean. And then you have an effective ventilation principle, where you, through the stack effect, can do intense and effective ventilation through openings in facade and roof. And this is a little bit shown on the drawing also. And then we must not forget what the humans want. They want to, you can say, look outside. They want to have a connection to the outside space. They want to hear the birds singing. They want to hear what's going on. And these are the psychological needs. So here is where the openable window is also very strong. It gives you that connection to the outside, apart from, of course, being good for stack effect or cross ventilation. And then we have overheating. So why is, you can say, cooling relevant in the world? We have regulation on insulated and airtight buildings, and this has consequences. You see this in the bottom. This gives elevated humidity and stuffy air. It gives a risk of overheating. But this really gives a need for ventilation and for cooling. And here it's very good to have, you can say, ventilative cooling, which can cool the building, and this gives a focus on the thermal comfort. And there are requirements in most European countries on temperatures, so the thermal comfort. Space cooling is, you can say, the amount of energy you need to cool down the building. So we really have to think of the right space cooling solutions. You can always install mechanical cooling, but it uses so much energy. So it's good to think of using passive cooling before active. So we're not saying you must not use mechanical cooling, because if there is a heat wave, it's a good idea to think of using mechanical cooling for that part. But for the remaining part, it's very good to open your windows, for example, using night cooling. Why is overheating an issue? We have seen peak and mean summer temperatures, which we estimate, or there are actually nice sources estimating that there will be an increase by 10 degrees across most European capitals by 2080. And also, there has been shown that the energy use for cooling of buildings rose around 200% over the 9-year period from 2010 to 2019. And we have also seen a 3 times increase in the global energy use for space cooling towards 2050, or at least that's an estimation, which could correspond to a 2 times increase in CO2 emissions for space cooling. So the world really needs to do something about cooling solutions in buildings, and here there's a huge saving potential if we design the buildings right and think about this in the best way. And then you can say overheating is not the easiest thing to understand, but on the right side, you can see that there are different sources to overheating. You have heat transfer from outside coming inside, and you can say a lot of heat gains inside. It can be by your working station or the wood, the fire stove, and the persons and the lighting, and all this can create overheating if you don't have the right building design. So it's not an easy task to understand, but there are many reasons for overheating, and at least ventilative cooling is one solution to mitigate this overheating. So it's just to know that there's a lot to think of during the summer period. How to mitigate this overheating that I've been talking about? You can use solar shading. For example, the external solar shading is very efficient for reducing the incoming heat. Thermal mass is the building structure, which can be, if it's a high thermal mass, it's good at absorbing the heat and releasing it during night. And here it's good to have, you can say, night cooling using openable windows. But also it's good, for example, to have surrounding trees for shading, so you don't get all the heat into the building at the same time. So there are many, you can say, design aspects to how to prevent heat, first of all, and that is very important to look into that. But if the heat has already come in, then you can use active cooling, air conditioning, which is a good solution. If it's extremely hot and there are very big heat waves, then mechanical cooling is sometimes necessary. But for a lot of the time during the year, you can use free cooling, or what we call ventilative cooling, where you can open your windows, and there can be different strategies during the day and night, because you can also cool a building during the day if the outside temperatures allow it. So that is, and then you have to make your strategy according to that. And night ventilation is strongest if you have a high thermal mass in your building. And on the right side, you see again example of a house where you can do, stag effect, and you can do different solutions. Here there are solar cells, for example. You can use that also. Yeah, ventilative cooling, I told you slightly about it before, but one of the problems in the world is that air conditioning represents 9% of the world's electricity use. And it is expected to triple by 2050. So we're really seeing a need to do something else. So we're not saying air conditioning is not the right solution. We're just saying, can we be a supplement to that when it's not extreme heat? So ventilative cooling is about using the outside air, for example, in the evening and the night, to cool down the building mass. And a good thing would be that you don't need devices to run during this time. Then you can save a lot of energy, and you can save the world for CO2 emissions. And what are the issues for ventilative cooling design? Well, for architects and engineers, we use, of course, the design tools because if you build a building in any EU country, you need to use what we call the compliance tools, right? So you need to comply with the regulations, and this is where you have these simulation tools or design tools to see if you can reach the targets of the legislation. So the current tools and approaches minimize overheating, mainly focusing on the detailed design stage. So there are many very detailed tools, and there is very low consideration of early stage design tools, where you take into account the stack ventilation, for example. So there are many country legislations that don't take into stack ventilation, and we of course feel that this could be changed. So also, if you're an architect, you have to just think about the stack ventilation in your design, because it's very effective. And the current design tools don't look into the holistic consideration of overheating and the linked design issues, ventilation and noise. So there are some things that should be improved. And then we have an example of a model, what we call the VELUX Model Home 2020. It's really a residential building, but here it was attempted to make a future building that would align with the future regulations. And it was built, as you see, in around 2011 or 2012. And here people lived in the house, and we tested the indoor climate. And here hybrid ventilation was used, so natural ventilation during the summer and mechanical ventilation during the winter. And it was found that the indoor temperature could be decreased by 5 degrees using ventilative cooling. And this was where you compared both simulations and measurement. And there was a 4-meter stack effect height between the facade windows and the roof windows. And you can see that in a drawing that there's a high, height difference. So this gave a good flow in the building. There was nice shading in the building, and people were very happy living there. And we achieved a high airflow during the summer, even when there was no temperature difference and low wind speed. So this means that there was a good ventilative cooling effect. For solar shading, it can reduce the overheating a lot. Solar shading protects the house from overheating in the cooling period, so during the hot periods. It enables to keep a sufficient glazed area for daylight and ventilation, and allows for useful solar gains in the colder months, because you take it up and down when you need it. And according to simulations from Ljubljana in Slovenia, by placing exterior shutters on roof windows can reduce the indoor temperature by up to 6 degrees and up to 3 degrees with internal blackout blind. Really effective to use solar shading on your windows. But this is also, it's both for, roof windows and facade windows. It's a good strategy to have. Then the question is, should you choose internal or external solar shading? Well, internal solar shading, for example, the VELUX roller blinds, they can remove between 11 to 25% of the incoming heat. Whereas if you take external solar shading, it's more effective. It's the VELUX roller shutter, for example. It can remove up to 93% of the incoming heat. So it's very effective, and you can choose the solution that suits you the best. And then we also have standards and legislation. And for example, what does the EU directive say from the EU Commission? And at the EU level, we have what we call the Energy Performance of Buildings Directive, the EPBD 2024-1275. This prioritizes reducing overheating through passive cooling measures. However, the passive cooling measures are not prioritized in all countries, and it's not all countries that are supporting fully the passive cooling measures, but since the EPBD is doing it, countries shall also follow this over the next many years. So again, passive cooling before active cooling would be a good idea. And also well-being is now a word used in the latest EPBD version. Also speaking of well-being in the beginning of the presentation. Then we have future building legislation. So to ensure, you can say, full compliance and ensure that you really fulfill the requirements, it is a good thing to have sensor-based natural ventilation or sensor-based hybrid ventilation, because then you can register the parameter you want to control. That could be temperature or CO2 or VOCs, whatever. And then you can open the window when needed. Because if it's too high level that the sensor registers, then it will open the window. And if it's not high enough, the level, then it doesn't need to open the window at that time. VELUX offers solution using our electric slope roof and flat roof windows, and our windows can be connected to sensor systems. We also have built-in solar cells, and that is good for resilience in buildings. So if the power goes out, you actually still have power because it's solar cells. And rain sensors, so the windows can close to flat position if there is rain. And then there is why to use ventilative cooling. Well, there are a few reasons. One is the resilience part. So buildings should be robust and the system should be robust. Ventilative cooling can support the robustness and resilience of buildings by using manual openable windows or solar powered solutions. So it means if the power goes out, as I said previously, you can still ventilate. And this is better than if you have a mechanical solution only, and if the power goes out, then you have no ventilation in that period. So hybrid ventilation is a good solution to have, so you can choose the system that is best for that time. And for the indoor climate, ventilative cooling can effectively reduce the building's energy use. And this, of course, what we said, instead of using air conditioning at that time. Then you have the environmental impact. Ventilative cooling can support saving resources and can be considered as a renewable energy solution for cooling according to the EU Renewable Energy Directive 2 from 2018. So actually, openable windows can be termed as renewable energy for cooling, and you can use it in your calculations. It's also good to know. There are new standards on the way in Europe, and the reasons that this is done is that you can say ventilative cooling or passive cooling or free cooling, whatever word you want to use, it was not really dealt with in the right way. So new documents were made both in the European standardization and in the ISO, which is the international standardization committees. And the plan is, of course, to support the European directive, so the EPBD. And these documents should refer to the right standards. And here we have something called performance requirements and calculation standards. So for example, you can also calculate your airflow rate in buildings by using certain European standards. These are usually EN standards. And so these documents are made to set criteria and give guidance to how to design ventilative cooling systems in buildings through a common design platform using, for example, openable windows. And this will help the designers, architects, engineers to know what to be aware of when designing these ventilation or ventilative cooling systems to fulfill the criteria you set in the beginning of your project. So I will just take you through 3 standards that are underway and will be published in the next years. One is called Ventilative Cooling Systems Design. Is for all buildings. The main purpose is thermal comfort, and it's going to be a SAN technical specification. It's applicable to natural, mechanical, and hybrid ventilative cooling. And this can be expected in 2026. And this will show you how to design free cooling systems for any building with a design procedure that all countries can use. And at one time, it could be hoped that it will come into national legislations also, but it's starting with the standards. And then there's an ISO standard called Design Process of Ventilative Cooling Systems Part 1. This is expected in 2027, and it's also for thermal comfort, so to reduce the overheating. And then we have another project which is called Ventilation Systems in Residential Buildings Design. It's the updated EN 15665, which some of you may know or may not know, but the main focus here is indoor air quality, so it's not the cooling. And this is applicable to all ventilation systems, so natural, mechanical, and hybrid. So this is expected in 2027. So there are many design standards on the way that will help you and guide you how to design systems for your buildings. Then there are, you can say, what I told you about the ventilative cooling standard. And in this standard, there is something we call the ventilative cooling potential method. And this can estimate the potential of the outdoor air for cooling in all locations in a simplified way. And here we have what we call ventilative cooling modes 0 to 3. On the right side, you see actually an output of one of the tools that are already available actually for you on the internet. So you can actually go online and you can actually find, you can find the tool and you can start working with it. And the output is what you see on the right side for every month of the year using your weather data. So that's like 8,500 hours or whatever, how many hours, but in an Excel file, then you can put it into your the tool here, and then you can get an output like this. So for example, you can see for VC mode 1 and 2, that's when you can use ventilative cooling. And then you can see if you need mechanical cooling or not. So that is very relevant document for architects to design a passive cooling system. And you can actually go on this link here, and then you can try it out if you want. And in the standard, we're doing a version 2, which is even improving it. So, but this was for you to know that there already exists a standard, a tool that you can use for design of free cooling. And the conclusions for this presentation is that openable windows in regulatory documents are, you can say, good for indoor quality all year, where you can use intensive ventilation, so you can do these really high airflows. Also good for thermal comfort in overheating periods, using ventilative cooling and solar shading. I think it's important to also remember the solar shading to prevent too much heat from coming in. And in the future, it's good to think about that performance-based ventilation systems for sensors is a good way to fulfill the regulations. Hybrid ventilation systems should be compatible with these, and this has to be thought of. And also, actually, there are some countries that have legislation on cooker hood requirements. But one thing that automatic openable windows can do is that in a cheap way, it can give you the supply air, because when you turn on your cooker hood, then it's a very high extract airflow. So unless you have supply airflow, then you don't suck anything out in your kitchen. And this has been seen in some low energy buildings, for example, in Denmark and some other places where there was not enough supply air through the mechanical ventilation system. So if you install automatic openable windows that is connected to the cooker hood, then you can get, all the air you need when you turn on the cooker hood. And for airing purposes, as I said, the manual operation of windows without sensors, it's good for intensive ventilation for quick removal of the pollutants when you feel like it, and if the power goes out in your building. Natural ventilation and ventilative cooling, if installed with sensors, are good to fulfill legislation and can fulfill the annual requirements based on, for example, maximum temperature levels, because there are requirements in many countries on how long part of the year you can have a maximum allowed temperature.
Super,
Yes.
Christopher. Thank you for this great presentation. I really enjoyed, and hope that the rest, all the people as well. Actually, before going to practice, I show some cases. Just to wrap up a bit, I think as an architect, we have a very, very important role how the future building will somehow withstand with all these climate changes, and also we cannot see the mechanical let's say, world of mechanical ventilation and the world of natural ventilation as separated words. We should combine it together and in a way that we get out the most out of it, the benefits of these two ways of ventilation. And I'm really happy that you said and announced the future tools the tools that are already available, as you said, how to predict if the airflow in the buildings is sufficient, that we can ventilate, that we can achieve the proper ventilation. Did I understood correctly?
Yes.
Yeah. Okay, so maybe let's talk more about it at the end. But before, we have some more slides, and now I will speak back. We'll start. We'll speak in Slovenian language. Torej, preden zaključimo, namenoma govorim v slovenščini, da nekako povzamemo vse tisto, o čemer smo govorili sedaj, tudi na osnovi nekaj praktičnih primerov. Pokazal jih je že Christoffer nekaj v svojem delu prezentacije. Bi pa mogoče omenila samo to, da vse to, kar govorimo, to vlogo kombiniranja naravnega prezračevanja z mehanskim, smo v VELUXu testirali in testiramo skozi vrsto različnih projektov, ki so realizirani bilo do sedaj. To niso samo stanovanjske stavbe, ampak so tudi javne stavbe, predvsem šole in vrtci. Zato dejansko želimo stestirati tisto, kar govorimo, in teh projektov je že kar veliko. Do sedaj jih štejemo 32, z zadnjim odmevnim projektom Living Places, ki je bil v Kopenhagnu. Christoffer je omenjal ta projekt v bližini oziroma na obrobju Pariza v Franciji. Jaz bi se mogoče dotaknila tele stanovanjske hiše pod imenom Sunlight House, ki je bila postavljena na obrobju mesta Dunaj v Avstriji. Hiša je praktično, narekovajih, že stara, no, stara ni, ampak ima praktično za seboj že skoraj 15 let. Na začetku, kar se rezultira tudi v izgledu fasade. Objekt je že takrat, v bistvu, s tem projektom smo že takrat želeli nekako stestirati, kako se obnaša temperatura v notranjih prostorih, če kombiniramo naravno prezračevanje tekom mesecev, kjer zunanja temperatura ne pade pod 14 stopinj, v zimskem času pa se uporablja mehansko prezračevanje z rekuperacijo. Se pravi, objekt sam tudi tekom poletnih mesecev ne uporablja energije za ohlajevanje, se pravi klimatskih naprav. Vse je bazira na prezračevanju, kot ga je Christoffer omenjal, ali to prečno prezračevanje, ali je ta efekt dimnika preko stopniščnega jedra. Vsekakor je pa odpiranje oken nadzorovano z senzorji na osnovi vhodnih temperatur, temperature, vlage in pa tudi CO2 v prostoru in pa obvezno zunanje senčenje. In v fazi izračuna, se pravi priprave projekta, je bila postavljena meja, da v nobenem prostoru temperatura ne sme padeti pod 27 stopinj, in v realnosti, ko se je to testiralo, v tej hiši 2 leti živela družina, 2 člana, se pravi 4-članska družina, je temperatura dejansko se ohranjala znotraj pod to mejo, kot vidite spodaj, maksimalno je dosegla 25,7 stopinj v bivalnem prostoru. Seveda ne testiramo samo stanovanjskih stavb, dobro je imeti tudi podatke od javnih stavb, se pravi stavb, kjer se zadržuje večje število ljudi. Tukaj le kažem primer iz Francije, iz Normandije, kjer je v bistvu šlo za preverjanje, kako 10-minutni intervali odpiranja elektrificiranih oken na objektu vplivajo na kakovost notranjega zraka. Dejansko se je učilnica prezračila oziroma se je za 10 minut so se odprla okna, preden je nastopil pouk, predvsem zato, da se tudi iz prostora grejo vse tiste hlepljive organske spine, ki se morebiti naberajo znotraj prostora tekom noči. Tako da tudi koncentracija ogljikovega dioksida se je zmanjšala znotraj v času, se pravi, odmorov. Namen je bil, da ko se konča pouk, da se odprejo okna, 10-minutni interval in vsebnost CO2 v prostoru je padla vsaj za 30%. Se pravi, tudi njihova regulativa ima postavljen normativ, se pravi, da mora biti ta parts per million delež vsebnosti CO2 v zraku pod 1000. Tako da, kaj to za sabo potegnilo, se pravi tudi vpliv jasno na temperaturo notranjega prostora, ki se je znižala nekje maksimalno do 1,5 stopinje, tako da ni bil tak močen odskok od temperature, od začetne temperature. Povzetek tega pa je, da je naravno prezračevanje v bistvu zelo efektivno. Praktično v 10 minutah so se znižale vrednosti CO2 za 300 ppm-jev, v primerjavi z mehanskim, ki potrebuje 20 minut za 100 ppm-jev. Se pravi, o tem je Christoffer že govoril, o tej podpori naravnega prezračevanja takrat, kad so res ti piki ali v vsebnosti CO2 ali lahko tudi v sami temperaturi. No, mene veseli, da imamo tudi v Sloveniji, da lahko pokažemo projekte, ki uporabljajo oziroma ki arhitekti gradijo, načrtujejo z mislijo na te elemente, o katerih smo govorili danes. Seveda, to je zagotovo samo eden od teh primerov. V sodelovanju z arhitekti studia AV, poslovna stavba Baumit v Trzinu. Na strehi ogromno nekih tehnoloških naprav, kot jih vidite, fotovoltaike, sta pa tudi 2 okni na ravni strehi in zdaj, če pogledamo znotraj, primarni namen seveda teh oken je osvetliti doprinos svetlobe v globino prostora. Zdaj, kljub temu, da so pisarniški prostori, da imajo zelo, bom rekla, velike zasteklitve na straneh, preko fasade, je tukaj pač vedno minus osvetlitve v globini in streha je pač tisti plato, ki daje možnost, da nudi osvetlitev, da v bistvu ta primanjkljaj svetlobe v sredini pride od zgoraj navzdol, kjer je pač ta intenziteta svetlobe od zgoraj navzdol praktično bistveno in bolj intenzivna, do 3-krat bolj. Da pa ne ostane samo pri svetlobi, pri dnevni svetlobi, je pa tukaj še možnost odpiranja oken. Ta okna so elektrificirana, zagorjeni so dežnim senzorjem, za dež, kar je opozoril že Christoffer, da je stvar nadzorovana, če ne drugega, zaradi zunanjih sprememb. Dež, okno se avtomatsko zapre. V prostoru nekih meritev ni bilo delanih tako natančnih, kot jih navadno delamo mi na naših projektih, ki so podvrženi konkretnim študijam. Je pa tukaj s strani arhitekta in uporabnikov zagotovo ta doprinos čuten, se pravi, da se vidi, da temperatura zaradi podhlajevanja v nočnem času zniža. Tako da to je en tak doprinos oken, ne samo v smislu osvetlitve, ampak tudi ohlajevanja prostora v poletnih mesecih. Zadnji projekt Living Places, o njem smo govorili že v enem izmed prejšnjih webinarjev, tako da dobrodošli, da si ta webinar tudi ogledate, poslušate, je objavljen na naši spletni strani. S tem projektom, ki je bil zelo odmeven, požel veliko arhitekturnih nagrad in podaja tudi nek koncept v razmislek, kako graditi v bodoče, kar se tiče stanovanjskih stavb. Nekako povzema vse tisto, kar smo do sedaj realizirali skozi vrsto projektov, ki sem jih pokazala na začetku. Poudarek je res na tej strateški poziciji vseh oken objektov, ne samo strešnih oken, vseh oken objektov, da dobimo tisto maksimalno lahko dejansko maksimiziramo vse tiste potenciale, ki jih objekt lahko da uporabniku. Zagotovljene so res hitre izmenjave zraka, nadzor je nad vlago, s tem uporabljajo se okna tudi za, jasno, ker pride do hitre izmenjave zraka, za ohlajevanje prostorov. Poudarek je na senzoriki, okna se ne odpirajo kar tako, ampak na osnovi podatkov, kdaj je smiselno in potrebno okno odpreti, in pa absolutno poudarjena ta vloga senčil, predvsem zunanjih, da ne prihaja do pregrevanja in pravočasno zaščititi objekt pred pregrevanjem. Za konec še neke vrste, kako naj temu rečemo, napotki ali checklista, napotki za načrtovanje. Jaz verjamem, da vse to, kar smo govorili danes, oziroma kar bom tukaj nekako povzela, že veste, in me veseli, da je tudi nekaj teh stvari napisanih v tehnični smernici Puresa, ko govorimo o sami arhitekturni zasnovi stavb. Ampak to, kar je že bilo omenjeno, se pravi, najprej razmišljamo, kateri so lahko tisti čisto pasivni ukrepi, ki lahko zmanjšajo pregrevanje stavbe. Seveda jih je pa potrebno komponirati in o njih razmišljati v začetni fazi. Od orientacije objekta, kolikor je možno v največji meri, do samega tlorisa, koliko toplotne mase damo v objekt, ki lahko prevzame tiste obremenitve toplotne. Nekaj, kar je za naše zdravje zelo pomembno, kakšne materiale dajemo v prostor, praktično na vseh površinah, od barov do obdelav, oblog in tako naprej in pohištva. Kot smo rekli, razmišljamo, kako lahko potegnemo iz obeh načinov prezračevanja največ, kdaj nam lahko služi naravno prezračevanje, kako ga komponirati v sam projekt, da zmanjšamo rabo energije in v končni fazi zagotovimo tudi prijetno notranjo klimo. Tukaj sem že omenila zelo premišljeno načrtovanje oken, da okno ni samo na neki točki pogled navzven oziroma vir dnevne svetlobe, lahko je tudi vir za ustvarjanje primernega toplotnega ugodja. In tukaj je mogoče pri prenovah, s katerimi se srečujemo in se bomo srečevali, smiselno razmišljati, kako prostore mogoče modificirati, jih odpreti, da lahko dobimo ta pretok zraka med prostori, jasno, da dosežemo specifike, katere smo si zadali. In to, kar sem že omenila, zunanje senčilo zagotovo. Jaz moram na tem mestu reči, da se kot ponudniki oken dostikrat srečujemo tudi z javnimi naročili, kjer se še vedno ali zunanje senčila predpisujejo praktično na vseh oknih, ne glede na orientacijo, kar se mogoče spet vprašaš o neki stroškovni smiselnosti, ali pa zunanjih senčil ni na tistih straneh, kjer bi bila potrebna in so planirana notranja senčila. Tako da tukaj zaradi tega mogoče te stvari toliko bolj izpostavljamo, ker smo tudi na strani ponudnika in v roke dobivamo projekte in vidimo, da lahko še vedno je prostor za izboljšave, tako kot vedno. Tako da mogoče to zaradi tega vse te nekaj, koliko jih je tukaj, 1, 2, 3, 4, 5 nekih točk, zelo kratek povzetek tega, o čemer smo danes govorili. Tako, za konec še napotki in pa kako do kreditnih točk, to verjetno vas bo najbolj zanimalo. Zdaj, po zaključku webinarja, v roku dobre ure, bom rekla, boste prejeli od nas mail, v katerem bo link do vprašalnika. Vprašalnik morate izpolniti, sploh tisti, ki želite pridobiti kreditne točke, ker tako vemo, da ste se vpisali na seznam za vpis kreditnih točk. Navedite zbornico, Med nami ste različni, ste člani Zbornice za arhitekturo in prostor Slovenije in ste člani inženirske zbornice, tako da navedite zbornico in navedite številko članstva. To bi opozorila, da res bodite pozorni, da navajate pravo zbornico, vzemite si mogoče kakšno sekundo več, kar se dogaja, da se zamenjate zbornice, pa se potem številke vpišejo in mi avtomatično gledamo po zbornici. Dostikrat dobimo tudi informacijo, da niste dobili maila. Preglejte nezaželeno pošto. Če pa slučajno se zgodi, da tega vprašalnika ne bo, maila ne boste dobili, me kontaktirajte na velux@velux.si ali pa direktno na moj mail. Kar morate vedeti je tudi, da vpis točk za zbornicama urejamo mi. Vi ne potrebujete narediti ničesar, vse uredimo mi in po zaključku, ki par dni to traja, nekako v drugem tednu, bomo poslali še potrdilo po elektronski pošti, poslano pa z mojega elektronskega naslova. Tako, zdaj posnetek bo objavljen na spletni strani, kjer imamo webinarje in kjer ste tudi dostopali do prijavnega obrazca. To nekateri že veste, objavljena bo tudi PDF prezentacija. Naj omenim še arhitekturno podporo. Z kolegom Dovnom Pogorevcem sedi v arhitekturnem oddelku podjetja VELUX Slovenija. Praktično Domen je tista kontaktna in stična točka za podporo v različnih fazah projekta. Tukaj res dam še enkrat poudarek, da se poslužujete te podpore od analiz osvetlitve do pomoči pri izboru ustreznih oken, detajlov in tako naprej. Praktično veliko je materiala in veliko je znanja v našem oddelku. Za konec pa še povabilo na dogodek Lunch and Learn, ki si ga lahko organiziramo skupaj z vami, se pravi, če vas je v biroju 3, 5, morda več, vabljeni, da nas kontaktirate, nekako združimo prijetno s koristnim, prinesemo kosilo, se podružimo za čas, uro ali dve, kakorkoli je na razpolago. Neformalna debata o tematikah, ki jih predefiniramo, tako da lahko tudi odgovore na vprašanja, ki jih imate z vašim projektom, tako da dobrodošli in vabljeni, da nas kontaktirate. Tako, tole je bilo, kar se tiče našega uradnega dela. Zahvala še enkrat vsem udeležencem za sodelovanje in za tak številčni obisk. Kot vidim, je bila tematika zelo zanimiva in upam, da je bila, ker je današnji webinar presegal število registriranih na webinarje, ki smo jih imeli do sedaj. Se bomo trudili, da bomo še naprej podali zanimive tematike. Na tem mestu se zahvalim tudi Christofferju Plesnerju in potem bomo podprli debato za, se pravi, prostor za vprašanja. At this point, I would like to thank you, Christoffer, for being with us. I've said a few words to the registered participants about, credit points, etc. As you saw, you couldn't understand, but that's that's the information that we have to give. So thank you for being with us. And at this point, we are ending the official part of our webinar. And we will stop recording. And we will open a debate if there are some questions that were in a chat box.